So, hello students. Today we will discuss very first chapter, which is limit in the calculus part, which is comes in the class 11. So, as I told you, limit. First, we will discuss start with the definition. After that, we can discuss one by one all the things which is required to calculate the limit. Okay, so limit, as I told you, if a function is defined in some domain, then we can say fx has limit L, which is a fixed and finite quantity. So limit L at x equal to a, where a is belong to the domain where the function is defined. If for all epsilon greater than 0, there exists a delta greater than 0 such that modulus value of x minus a less than delta implies modulus value of f of x minus L less than epsilon. So if all these conditions hold, where delta epsilon and delta, what is the epsilon and delta exactly, we can discuss later, and I will show you with the help of one example how we can find a delta and epsilon and delta. Okay, so there is all the things we can discuss one by one, don't worry, but first of all we have to write complete the definition, that is, if all the things are followed, then we can write the function limit x tends to a f of x is equal to L. Okay, so this is the definition of limit. If all the things exist for the function, then we can say that the function has limit L when x tends to a. Okay, so here, as I told you, we will read it as x tends to a. Okay, but so what is the meaning of x tends to a? The meaning of x tends to a is that we can calculate the limit of a function at the nearer value to a, that is closer value to a, not exactly at point a. Okay, so we can discuss all the things. So this is the definition. So all the things in the written definition we can understand with the help of example. Okay, so let fx is equal to x square minus 1 upon x minus 1. Okay, so this is the function. So with the help of this example we can see all the literal meaning of all the things written here. What is delta, what is epsilon, what is delta, and what is this, and how we can calculate this. Okay, what is the meaning of x tends to a? So if we see the value of function at x equal to a, at x equal to 1. Okay, so then we can say that f of x is equal to 1 gives what? 1 square minus 1 upon 1 minus 1, which we find as 0 by 0. Okay, so for now this is a for now we can say this is a meaningless quantity. It is a indeterminate form, but we can discuss all the indeterminate forms and how we can find the solution if their function goes to a indeterminate form. Okay, so for now we can say that this is meaningless quantity. Okay, meaningless quantity. Okay, so for x equal to 1, we can say that this function gives a meaningless quantity. But what about if we take some closer value to 1 but not exactly to 1? So next thing, at x not equal to 1, we can say that f of x, we can write here x square minus 1 upon x minus 1. We can solve this x plus 1 bracket में this is a square minus b square, then we can write it one bracket में x plus 1, in another bracket में x minus 1, and in the denominator x minus 1. So here we can see that this x minus 1 can be cancelled out. So finally this function convert into the x plus 1 form. Okay, this is for not x equal to 1. Okay, so we can say that how we can calculate the limit for this function. So let me erase this. After that we can see how we can find the limit and what is the meaning of the all things. So let me erase this first. So as I told you, here at x not equal to 1, we can say fx converted into x plus 1. So let find this value at x is equal to, first we can say, we can take x less than 1, and second thing x greater than 1 but closer to 1. So first value we can take x is equal to 0.9. Then we can find value f of x as 0.9 plus 1, that is 1.9. Okay. Second thing is what? If we take some closure, this is the closure value to 1, but we can move nearer to 1 as taking the value 0.99. Okay, so we can find the limit of this function as 0.99 plus 1, that is 1.99. Okay, move one step forward, that is x is equal to 0.999. Okay, so we can see that f of x is equal to 0.999 plus 1. We can find this will become 1.999. So you can see here, as we move nearer to the 1, then we can find the function value f of x move closer to 2. Okay, so we can write 1.998, not exactly but closer to 2. Okay, so this is the limit of the function from left side. Okay, now we can take some other value as greater, which is the greater than 1, as we can take 1.1. Okay, so we can find functional value at x is equal to 1.1. We can say that 1.1 plus 1, that is 2.1. Okay, move closer to the 1, that is we can take x is equal to 1.01. Okay, so functional value we will find 1.01 plus 1, that is 2 plus 2.01. One more step, we can move forward, x is equal to 1.001. Then we can say that f of x is equal to 1.001 plus 1 is equal to 2.001. Okay, so with the help of this example, we can simply see that as we move from the left side to the nearer to the 1, and from the right side to the nearer to 1, so we can say that this also almost converted to 2. Okay, so in this case we can write this function limit x tends to 1, x square minus 1 upon x minus 1 gives limit 2. Okay, so here is the literal meaning how we can calculate limit. Okay, but in the definition we will write, we have written two things, that is epsilon greater than 0 and delta greater than 0. Okay, so if we see the actual value of the delta and epsilon, then we can find here. Here is a is equal to 1, but we take actual value of x as 0.9. Then if we subtract x minus a, then we can say that this will equal to delta. So here we will see here what x is equal to, we can take 0.99 minus, this is a, not 9. So we put here 1, then we can simply found what 0.0001. Okay, let's suppose this will become, so we can say that this is the delta. For corresponding to this we can find one epsilon. So what is the epsilon? As I told you, we can calculate value L, which is equal to epsilon. So corresponding to this we can find value of what? Function 1.999. Then we can say that here function value at x equal to 0.999, we can see here 1.999 minus what is the limit here is. So you can see simply this will become what? 0.0001. Okay, so in this case we can we find what? Both the limit, both the quantity, that is delta and epsilon, both are equal. Okay, so this is the literal meaning of delta, epsilon and limit. How we can find what is the meaning. Okay, now we can discuss the steps involved to calculate the limit and algebra of limit. And as I told you in the beginning of this is indeterminate form. Okay, so we will discuss this also as a topic. After that we can start solving question. Okay, so